Hello everyone. Today I will be talking about a brief summary of how to write quantities in chemistry effectively and professionally so that your scientific writing should be accurate according to the standards that are developed by IUPAC or other scientific communities. I will be emphasizing on few points. So first of all, I will explain what is the importance of this topic. Secondly, I will provide some resources so that you can learn more about this topic. Furthermore, particularly for this topic, I have divided this quantity and measurements heading into three different components, including number, units, and how to measure uncertainty. And moreover, I will present some symbols and some rules for writing symbols or explaining symbols during your quantities expression in your writings. At the end, I will discuss few odd things that are actually present in these rules. So first of all, whenever you are doing some research, you are doing some experiment in your lab, you have to report your results. So how accurately you are reporting, that actually depends which way of reporting you are choosing. So for that, it is always recommended or preferred to use standard reporting ways. So for particularly talking about chemistry, IUPAC standards, they are the main standards for explaining or reporting your values for particular quantities. This will help you in improving your writings. Moreover, it will reflect that your writing is a professional writing and according to the scientific community standards. Moreover, your data presentation will be clear and it will be easy to understand, easy to follow by layman as well as by scientific community. Similarly, there must be a consistency in your writing. There must be a flow in your writing so that people can understand what is your main aim of your project and what are the findings for that project. So here I have mentioned few resources. The first of all, IUPAC Green Book, that is available online, and it is explaining different SI units and different other definitions. The second resource is actually the basic definitions of concepts in the science of measurement, and it is also very helpful for explaining different specific terms for scientific quantities. Moreover, the guide to the expression of uncertainty of measurement, that is actually one of the important parameters for the validation of your reported result, can be easily learned by the given link. For quantity and measurements, it's not limited just to chemistry, but physics, material science, chemical engineering, and all other different fields where collection of data and interpretation of that data is important. So value of a quantity is actually a terminology that is being used for these kind of disciplines. So what is quantity? It is actually a characteristic of a system or characteristic of any device that is actually identifiable and it has some value. For example, mass, volume, concentration, and there are many examples in this context. So when there is an intention to measure quantity, then that quantity will be called measurand. So measurand can be divided into three parts. So for expressing measurand according to perfect scientific way, the first thing, it contains numbers. The second is the unit of that quantity, and the third, that is actually the expression of uncertainty during your experiments. So for example, in these examples, 3.4 is the number and unit is milligram, likewise. So for number, it is actually in the form of a value. And what is the proper way to write these numbers in our writings? these numbers must contain significant figures, and we should be talking, or we should write these numbers in scientific notations wherever it's applicable. There are some units where we can use prefixes as well. For example, 2.3 into 10 raised to the power minus 7 amperes can be written in the form of 0.23 microampere. So that is more convenient and easy to understand. So after number, units is the component for value of a quantity. So normally we are using SI units, but other units, they can be used particularly when you are dealing things in industry or some other commercial levels. So for units, we should type units in normal, not in bold or italics typing, and we can use units in the form of their name, and we can use abbreviation instead, but units are never plural. So when you are referring a unit in a text, then we have to use its name. Otherwise, when we are talking about quantity, we are using abbreviations. So name of unit always starts with lowercase letter, and it's same for all of the units, whether units they are derived from named people or they are not derived from scientific names. Abbreviations of units that are named after people can be used with can start with the small d for Dalton when you are expressing it in text, but when you are expressing it in the quantity, then you should use capital D before in its abbreviation. So important point regarding units is that there must be a space whenever you are writing number and a unit together, and when you are using two different units together in a quantity, expressing the value of a quantity, then there must be a space between two different units. So for example, here there is a space between 5 and milligram, and there is a space between 2 and mole, and there is a space between mole and liters, but there shouldn't be any space between the prefix and unit. For example, here there shouldn't be any space between milli and mole. However, whenever you are expressing your units as a division, then there shouldn't be any space on the either side of this sign. So after describing units, the third component for expressing values of a quantity properly is measurement uncertainty. So it is actually is representing that how your repeated values they are similar, what is the validation of your data after several number of repeats. So now we are using standard uncertainty with the symbol U, and we are calculating this uncertainty in the form of standard deviation. There are different number of repeats. People, they are using 3 to 5 repeats for calculating uncertainties for a particular data. So important point for measurement, writing the uncertainty with your quantity, we have to match the decimal places of the number to the significant figures of the uncertainty, and normally it is 2. For example, here in this example 8.89, so after decimal there are 2 digits, and when you are using uncertainty with this value, the decimal point, after decimal point there must be 2 digits in uncertainty. So in scientific writing there are symbols that are actually used to avoid writing the full name of a quantity, that is tight sum. So it is advisable and recommended that always use IUPAC symbols. For example, for concentration the symbol is C, and for number of entities symbol is N, and for electrode potential like symbol is capital E. So symbols for quantities and any other variables, they must be written in the form of italics, and symbol for fundamental constant, they are also written in the form of italics, and you can label them in the form of in normal font. So here we have some examples of symbols. So capital Na is the symbol for Avogadro constant, and Ci is the concentration of the ith component. So at the end, I will discuss few odd things. So the first interesting point regarding this discussion is that 1 is actually a unit in SI. In standard international units, 1 is a unit. So in many examples, you have encountered that there are some quantities where we are using, actually there are no units. So actually there is a unit that is called 1, and in SI unit 1 is actually a unit. So there is nothing like no units. So and it is recommended by IUPAC that it is better not to cancel units. If you are leaving them as such, then they can convey some good information. For example, here if you are talking about mass fraction, that is the ratio of two masses, then we can write gram upon gram. So this expression, that means 1, but it is actually clearly explaining that how we have calculated this mass fraction. So another interesting rule that is coming under this heading is liter. It has exception to the capitalization rule. So for liter we are actually using a capital letter L, not small letter l. Similarly, for molar, that is actually moles per liter, IUPAC actually recommended to use capital M, its unit, SI unit. So the SI unit of time is actually second, but it is a very common mistake students or scientists or other people in their reporting. Sometimes they are mistakenly writing it as SCC or SECS, but the true SI unit for time is only small s. So there are some other units that are also allowed for time, including minute, hour and day. Alright, so this is all about our discussion regarding this topic. Your comments and suggestions will be highly appreciated. Thank you.